Raj, I love it. I love the hat.
I'm trying, yeah.
Yeah, I got the mug. How
Hmm.
was jury duty?
Jury duty. Oh, I had a heck of a case, but it was very fun. I learned a lot about that, and it was kind of 3 days with 12 people from, your town like that. So it was quite the experience.
Oh wow, good. Well, I'm glad you still make it today. And so Raj is going to have I think this will be the longest talk, just a bit longer than the other presentations, because Raj is going to explain every type of evaluation there is and can ever be. And then we will hold his questions to the end, but you can still put them in the Q&A, and we'll get through as many as we can at the end. So, Raj, whenever you're ready.
All right, let me kind of share the screen and let's get this kind of started on this. All right. Um, Now, as we go through this, a couple of pieces I want to kind of highlight here is I'm going to talk about evaluation with large language models. I won't be able to see the questions coming in. Amber, let me know if there's anything really important, but my goal is to get through this material in about a half hour. So I'm going to go
Okay.
fast. It's going to be technically deep, but then I'll leave plenty of time for questions at the end, like that. So
Okay.
that's my plan. Um,
So
if you want.
flag the emergency questions.
Exactly. Yeah. Like if there's something like, hey, Raj, like you totally missed this. Like this is an obvious piece that everybody's complaining about. Like feel free to kind of stop me like that. But otherwise, yeah, let's keep them till the end. Though I've made the slides for this talk available. So if you go to the GitHub repo, you can even see the slides so you can follow along. If you want to grab some of the links as I'm talking about them because you want to look up a paper or you want to look 3 slides ahead, feel free to do that as well. Now, I am going to ask one thing is I want to make a few short videos. I do TikToks and Instagram Reels on this stuff. So I am going to ask people at the end, like, what are the 2 or 3 things that they thought were really interesting that I should like make a short video on? Because I need to do a little bit of research like that. But let's go ahead and kind of dive into it now. I'm resetting my timer here. When we start talking about how we can evaluate a large language models, the predictions that come out, there's a lot of different ways to do this. And I've done this kind of exhaustive mapping of all these different ways and even kind of mapped out this kind of on the basis of overall cost and flexibility. I'm not going to have time to go through all of these things today, but I do have a YouTube video which goes in for an hour and 20 minutes, so much longer than today, that goes into each one of these in much more detail. So today, there's exceptions, there's edge cases that I'm not going to be able to cover because of that. But if you want the full deep dive, that's where we go. For today, my plan is I want to start by just talking about why evaluation is so difficult with LLMs, especially if you came from a background of traditional machine learning with logistic regression or XGBoost. Evaluation is way different when we work with these LLMs. Beyond that, there's 2 interesting trends that I see that I wanted to highlight today. One is the idea of using a model as an evaluator or judge. So instead of just relying on humans to label our data, for example, we can use models. We'll talk about that. And then finally, how we can use LLMs to explain their predictions. If you've been in traditional ML, there's explainability techniques. I want to see, hey, what can we do along those lines here with large language models? Now, when we talk about large language models, we know we can use them in so many different ways. We can do summarizations, question answers. We can kind of get them to generate code. And for people in this area, you probably are like, okay, well, if I want a large language model, maybe I'll go out to something to the Hugging Face's open large language leaderboard to be able to identify one. But if you've been in the field for a little while with these leaderboards, yes, they're nice that they give a couple of objective criteria to do it. But we also know that all these data sets aren't necessarily relevant to the particular use case that we're working on. And these models, right, they'll vary quite a bit on the ranking based on how they can do on this, where just a little bit of difference in, for example, a truthful QA can make a big difference on where they land on that leaderboard like that. So it just makes us wonder, how reliable is this for kind of when you're selecting an LLM? There's other leaderboards. The folks over at Stanford have the holistic evaluation of language models. And there you see some strange stuff. Like you see like the older version of the OpenAI model is ranked ahead of the newer version. And look, I tease the OpenAI folks all the time like that, but I don't think they're going to make a newer version of a model that's much worse than their older. So it just makes me wonder about the reliability of this. Now, people have been working on this. There's some better leaderboards. So for example, for chat, there's things like Empty Bench or the Alpaca eval that are better ways to evaluate these models. But at the end of the day, like it can be really frustrating. Here's an example where you look at the LMSys chat arena board for the Claude models, and you see the humans think the original Claude model is better, but Anthropic's benchmarks show that the later versions, the Claude 2 is better. So it's just like, it's just so frustrating if you're in this field to try to figure out kind of what large language to use. And part of this is I think we have to think about how these leaderboards are, that often they've been built for this idea of I have 2,000 different models and I need to figure out which ones are better than others. But if you think about how you're actually using these, if you think about the problems you're actually solving, it's not about figuring out and ranking 2,000 models from best to worst. It's really what you have is you have a particular problem and you're trying to optimize that model for that problem. And so this is a much more of a system perspective. The folks at Perna has a nice blog post, maybe Amber helped write that as well, that kind of talks about this, where I kind of grab these graphics from. Because here's the thing is, when you're building a system, when you're solving a use case around this, evaluation is critical to helping you understand how that model is performing. If you want to get through this thing faster, if you want to get a better performance, if you want to get it cheaper, all that's important. Now, some of the variables that can matter through this is we'll talk about the stuff that goes in the models themselves, as well as the outputs. And my favorite story about this is the MMLU leaderboards. So Hugging Face, we love top ranking models, we love open models, and as soon as one comes out, we happily tweet about it. Thomas Wolf did this about 6 months ago. Look at this great model, look at the score. Now, a few people will, let's double check the results and said, wait a minute. The numbers that you're showing for your particular model are different than what's in the paper. Like, what's the deal there? Why is this different? And the folks at Hugging Face spent a little bit of time researching this. And one of the things they found out is we're working with this MMLU scores, which, and if you're not familiar with this, it's basically a data set around knowledge understanding, like asks questions about history, computer science, mathematics. It's multiple choice, but how you do on that matters. Even a few percentage points can alter kind of where you rank compared to other models. Now, when they started digging into this, there's about 3 different ways people were evaluating these models on that. And here's the prompts for each of those. And if you kind of stare at these prompts a little bit, hopefully you can kind of squint through them, through all this, you'll see there's some slight differences between the models, right? There's like an extra space in the Helm, like there's no topic line in the Eleuther one. There's a question prefix in one, but right, other ones use choices. Now, some of you might be like, come on, like, shouldn't these models be able to figure this stuff out? Like they're passing medical exams, but you're telling me this is different? Well, yeah, I mean, and our friends over at Anthropic have kind of noticed the same thing and published a post where they talked about when they were working on MMLU evaluation, just some tiny formatting changes, going from the parentheses A to the number 1, or changing the round brackets to the square brackets, or adding an extra space. These things actually mattered, and they changed the score in the evaluation. And this isn't just like accidental things. A lot of people, and this is where a lot of people kind of eye benchmarks with a little bit of kind of suspect, is because that prompting style can really affect the benchmark. And so you saw this with Google and the Gemini model, where Google advertised a score higher than GPT-4, but they were using a different prompting approach. And if you actually leveled it and compared the similar prompting approach, and Philip did that on our team, you see that the Gemini model doesn't do as well in this particular thing. So these are the nuances that comes into, and why evaluation becomes so difficult is all of this. Besides that, there's the model itself. When you go and look at this, and when we start talking about models, for example, a given provider might have different models of different sizes, different generations. Each of those can give very different outputs. So here's a result from one looking at the political bias of models, where there's quite a bit of difference between GPT-4 and GPT-3.5, right? Trained by the same people, the same team, right? Are somewhat the same data, but still very different outputs for this. Beyond that, whenever we ask a model for a response, most of you would probably assume anytime you give it a certain input, you'd always get back that same output. And if you grow up with traditional machine learning, like XGBoost, logistic regression, you get inference that's deterministic. But when we enter this world of large language models, that all goes away. It's very easy to get outputs that are very different, or outputs that are different, even though your input has been the same. And this is for those of you who have to worry about reproducibility. If you're inside enterprises that do this, this is a difficult issue to deal with. Now, OpenAI's added a new seed parameter to make their models more deterministic. I have no idea if it's 100%. It looks like it's pretty good along those lines. But beyond kind of that piece of the deterministic is, if you're working with commercial APIs, those things can also change over time. So that's another kind of control that you have to do. Now, finally, when we talk about that outputs of these models, if I'm doing something like MMLU, you might think, hey, this is pretty simple. Like, it's multiple choice. Like, how complicated could multiple choice be, right? Like the Scantron, you just fill in one of the things. Well, yes, you might do it that way where you have 1 out of 5 choices, but you might evaluate it, for example, where what you want to do is take a look and say, when I get an answer back, I'm going to look at the first letter, and that's the answer I want. Some of you might say, well, you know what? I want to take a more holistic approach where I'm going to look at the entire answer and evaluate it. And this isn't fictional. When we started digging into how people were evaluating the MMLU data set, we saw people were evaluating on different types of outputs, and this had a material effect on the overall performance and actually changed the rankings of particular models like that. So these are all the things you have to kind of take into account when you're doing this, and why often you see lots of people having to do multiple iterations to really get this stuff, to get some consistency in this. Okay, I'm going to take a breath here. This is the first of the kind of the 3 bullet points I wanted to hit. Now I'm going to jump into the model-based approaches. Now, there's lots of ways for evaluating large language models. I think the model-based are really one of the most interesting ones to me, and why I want to spend time today talking on it. At one point, I tried to map these out, like in terms of cost, and I think model-based approaches, as we'll talk about, are kind of really cheaper than others, as well as they offer quite a bit of flexibility. It's not the same as kind of human evaluation like that, but I think they're an interesting point here to do that. And again, right, go watch the video if you want the deep dives on the rest like that. So let's jump into kind of this model-based approach. And as a starting point, most of the evaluation is often done by humans. We have them look at the results of the model or maybe label some data that way. And what we want to do is we want to substitute the human with a language model instead. Now, and maybe this person's even on the webinar, there's a lot of people that are skeptical about this. Like, how can you use a model to evaluate another model? Like, and especially if you come from like traditional machine learning or something, like, and how would you ever use like another churn model to evaluate how well your churn model is doing? Like, it doesn't seem to make sense. Like, it seems like you're just like stacking a house of cards that's going to fall down like that. But as we talk about, like, this stuff can actually work. And, we've got a few bullet points where we've heard some stories about how it's working. Databricks shared how they used a model to evaluate data quality. And based on that, they were actually able to improve the overall data quality in doing this. So let's walk through like a more concrete example. Suppose you're working with the marketing department and they asked you, what we want is, yes, your large language model is going to give us new content, but we really want it professional. And looking over at you is, right, that machine learning engineer, data scientist in the hoodie, they're like, let me describe for you exactly what professional is, because you might not, get it. Now, this is what professional is. It's something formal, respectful, that's tailored to the content and audience, something that isn't casual language. So the traditional way you'd want to do this is, if you have to build an evaluator for this, you'd be like, okay, marketing department, like give me 1,000 paragraphs and we'll go out, we'll label these paragraphs as professional, non-professional. I'll train a model to do that. And we'd have the human kind of label it in that. But what I want to show you is we can have an alternate way here to be able to do this. And we're going to use a model. And what we're going to start with is we're going to first, for the model, we're going to define exactly what we mean by professionalism. And you'll see this at the top, and hopefully it's big enough on your screens that you can see it, or otherwise grab my slides and blow it up on another screen next to you. But first, we want to define what professionalism is. And then we tell the model and we give it a grading scale. So, 1 point if it's extremely casual, on the 5 points if it's noticeably formal. And then the last thing we're going to do is we're going to specify what model we want for evaluation purposes as well. Now, to give you an idea of what this will look like is imagine you get an output of the model. And so you can see that at the top, like here's the output that comes out of your language model, but now we want to score it. What you'll end up with is a numerical score, that grading score that we talked about, and then the justification or explanation for why that is. So hopefully this gives you a little bit of colored example of like how something like this would work. And if you step back, you can see, okay, this isn't too crazy what we're doing around this. And there's actually simpler areas where you can think about this, where suppose you just want to make sure like the response that's coming out of the model is not too long. You just want to say, hey, it's got to be no more than, let's say, 50 words. Well, right? You can use like a simple like regex-ish type thing, right? An easy or end characters or some way to measure exactly how long the response is. Like you don't even need a model. You can just write a rule to do that, right? That doesn't seem too crazy to do something like that. I know for a long time we had models that would identify what language some content was. Again, like you don't even need a transformers-based model for doing that. Other times, maybe you want to evaluate is, what's the sentiment that's coming out, or what's the toxicity of the content? And again, like these are pretty well-established problems. Like it's not too crazy to kind of have a model do this. And so I think if you start with like, there's some areas where we're pretty solid areas for kind of using model-based evaluation. And I think the best way to kind of use this is to combine this with another approach that I talk about, which is called functional correctness. And the idea here is you don't use a model to evaluate just the entire thing that you're trying to do. Instead, what you do is you just break it up into kind of smaller tasks, or you can think of it like unit tests. So if I'm trying to evaluate these emails for marketing, maybe I'll have different criteria for different pieces where I want to say, is it concise? Is there something actionable? Is the tone polite? And you could think of this like having this checklist of criteria, and if the message meets all of this criteria, then we pass it on like that. And folks are already building this kind of thing. Like, so we see this was a recent paper that applied this to instruction following, where they had something like 50 different criteria. And you can see the criteria here aren't that crazy, that to kind of be able to evaluate content for that. Now, when we kind of use this model-based evaluation, we can use that same kind of framework that I laid out earlier, where one thing you can think about is if I'm doing model-based evaluation, like what should the prompts be for that? Like the professionalism I gave you was a pretty simple, straightforward prompt, but there's folks that are using fancier prompt things like chain of thought, where when we do the evaluation, based on that input that comes in, we ask the model, hey, come up with an evaluation plan for evaluating this particular input, and then go step by step through that. So, right, many more calls, more sophisticated, but maybe that fits the problem that you're working on. Now, this type of approach, the folks kind of spend some time doing it, and I think this is good for us to understand in general. These things actually align quite well with how humans would grade something. And so I have a couple of papers like this in this talk, but generally we find that there's a pretty good agreement between how the models are scoring something to how the humans would score it. And you can see here, this is one graph that I really like, is for most of the scores, the models in this particular case, this grading assignment, all the same. Now, there's a section of it, a small section, that yellow, where you can see there's a difference of 1, but very few was there a strong difference between how the human graded it and how the model graded it like that. Here's another one, and this one actually shows a little bit of a trend that we'll talk more about in kind of the biases of these models. But you'll see that in that middle area, in 2 of these, you can see the GPT summaries were kind of ranked better. But when the large language model was considered better, you'll see the score is much higher here than the human. And what happens is there's a little bit of a bias where if you ask these models to evaluate themselves on their own type of language, they like themselves. So they kind of grade themselves a little bit better on their own type of words that comes out. So it's a kind of a bias, but it's something that we can manage when we talk about this. So another example of kind of what we can do with prompting is the self-check, which was used around hallucinations, where the idea was you want to get lots of different responses out of the model, and we're going to see how consistent they are as a way to detect hallucinations like that. So lots, and there's going to be a lot more research as model-based evaluations do, but you can see there's a lot of things going on the prompting side. When we get to the model side, most folks will say, just use GPT-4. It's the strongest evaluator out there, which is fair. And sometimes like, hey, can you use 4, but maybe you want to try 3.5 for production use because, right, when you get to larger volumes, that could be costly. One of the other things we've seen is some recent papers talking about training your own particular model for your own particular task as an evaluator. So some papers like Judge LM, the Prometheus is kind of very promising. And I know some of the folks I've been working with have been playing around with that, where it's a very strong model. It kind of, when they looked at the correlations between that and humans for the tasks, that it was very strongly correlated with GPT-4 on that thing. And this is something that you can then fine tune for your particular task. And also, right, it's also has the other advantages of an open source model that you can kind of own it yourself as well. So, a lot of options are growing here for this model based. I didn't mention earlier, but like when we're thinking about like the content models, well, Meta released Llama Guard, which helps us kind of identify toxic material as well. So that's another kind of model-based evaluation that you can include in your framework. Now, when we're doing this, we can also, the outputs of these models can be quantitative. And this is one of the things people have figured out over the last years. When we do this, we really want to use a lower precision grading scale. Just fewer things, even binary is probably preferred over the best. Now, there's been some people trying to figure out ways to kind of get probabilities out of this. And right, there's a whole other thing about, can we get uncertainties out of models? And I'll mention that kind of later. But for the most part, I suggest sticking to kind of these lower precision grading scales around that. Now, just like humans, if you do human-based evaluation, there's a whole set of biases with that. Models come with these as well. Some of the things we've already noticed are position bias. And again, humans are affected by this just as well. Like they tend to favor the first response if you give multiple positions. LLMs like the longer, wordier responses over concise ones. Anybody using these models for a while knows that. As I mentioned earlier, they kind of they have a bias towards their own language, towards their own answers. Now, there's ways to ameliorate all of these. So ways we can kind of deal with this is swap the order for position bias, for the verbosity bias. We can make sure our comparison lengths are similar in length. And then to make sure LLMs, to address that bias that LLMs have for themselves, well, don't use the same LLM for evaluation tasks. Use a different evaluation for what you're doing in the model versus what you're going to use for evaluating as well. All right. And so that's kind of a quick kind of a synopsis on kind of model-based evaluation, which I think is growing kind of has a lot of promise in there. In the GitHub, I have examples of a couple of code notebooks. I think Ragus was an early package, but even lately, think folks like MLflow have added this. Of course, our folks at Aries have added model-based evaluation. So there's a lot of places there that's mentioned in the GitHub. The other thing that I have there I have some example prompts. So if you're like, hey, how do I prompt to do this? Well, in the GitHub, I have prompts for how you do data quality or factuality or kind of build a grading scale if it's the first time through all this. All right. Last section I want to go through. So hopefully I'm on time and hopefully there's not too many crazy questions built up at this
You just
point.
got a few built up, like
Okay.
not too many,
All right, good,
like
good.
4 or 5.
All
So
right. And I'll be asking the rest of you what are the cool things you like so far. Okay, so let's talk about the last piece here. Explaining your predictions. And I haven't seen a lot of this in the literature, but it's something that's really driven by my own personal interests, where I use these models all day long to do like text classification. And it's nice to like get an explanation of it. And part of it is I was just like, how useful is this? How reliable is this? And I come from a traditional machine learning background. I spent a lot of time, you can find lots of earlier papers I've worked on that have focused on explanations in the world of tabular, where we have tools like, for example, SHAP that let us explain what's going on for these models. And this is really useful because it helps us if we want to try to improve or diagnose the issues with our models. If somebody comes to us, right, our boss comes to us and says, hey, why is this model saying this? The explainability tools help you do that. There's also this issue of like, hey, can we get the certainty of these predictions? Is this model really confident about this classification or not, as well? And the thing is as soon as you dig into these models, like try to like the black box, these models are just literally so hard to explain. Like they have so many parameters and they're so complex. Now there's folks on mechanical or something like that, interpretability, that are trying to do this, but I haven't seen them make much progress on this front like this. So, we can't look at coefficients the same way we did for logistic regression. But one thing I've already seen people writing about is how you can use explanations to improve the performance of the model. So this was a paper on information extraction that found out that the explanations in the model were better than the ground truth. They were like, and so that tells you something right there, that like it's when your model is given something better than ground truth. Here's another paper where you can think of few shot learning, where we give it an example, where they gave it an example, but also the explanation from the model for that example, and then fed that in as part of the prompt. And that actually improved the model by adding that explanation. I know this is another one I stole from you guys, where the Aries folks kind of did some testing where they wanted to get answers out of a RAG model. They also included the explanation. And you can see in my graph here that when they used the explanations, that the model performed a little bit better. And this is the bonus that you all get for coming to this, is if you actually look at the blog and look at the results, you'll see that I very cherry-picked these results. The actual results in the paper, in the blog, actually don't really show this relationship that strong. I picked one example where you see this, but it's not clear in the paper whether explanations are beneficial or not to the overall model performance like that. But despite that particular data point, we have some other data points where we know if we're doing, for example, text classification, having those explanations can be very useful in explaining why the model picked a certain category like that. We've seen this also in others for things like recommendations. And again, this is another reason. Jason kind of mentioned in the Slack that he was working on a code generation project, and having the explanations was useful because it pointed him right away to what the problems were in there. Now, these explanations aren't always perfect. I think one area where we've seen a little bit of gray area is when it's a very hard problem. When it's a hard example, the explanations from the model aren't as useful, as well as if we really make it hard for the models, if we kind of bias the model towards an answer that it shouldn't be giving, but we kind of push the model to answer it that way, the explanations will often turn into justifications. And so this is always something to remember when we talk about explanations with these models, is they're explaining why the model did the prediction. They're not separate from the prediction necessarily. They're not getting to the truth of the problem. They're just kind of pointing out why the model did something. So if your model does something way off for the prediction, the justification is probably also going to try to kind of be in that alternate world as well. Now, when you're doing this, of course, there's a cost to this, right? There's a compute latency cost for explanations. And so it doesn't fit for every type of use case when you're working on it. Now, to get explanations, you might think, come on, how hard could that be? Well, let me tell you. Depending on how you do it can actually make quite a bit of difference. Do you ask the model to predict first and then explain? Or do you ask the model to explain and then predict? Now, if you're in math, like there's like some associative communicative thing, right? Like both of these should result in the same thing, right? But in this black art of prompting world that we live in, no, they don't. And there's a couple of different studies that have been kind of looking at this. And so here they've given it examples, and you can see in this example, this was a predict then explain, because you can see the answer here that has been prompted with is to give the prediction and then explain it. And they run this both ways. And I mean, if you squint at the results, maybe it's better to explain and then predict, but it's not necessarily clear. There's, other papers. This one did it in the context of like, rate something and then explain it, or analyze it and then rate it. And again, like you gotta like squint through, and if you read the text of the paper, they actually say, you know what, try both. See what works better for you. You might have to go with that. If you want to, you could kind of really average them. I've run my own tests. I haven't found a clear one. I think it depends probably on the complexity of the task. Does help thinking about it step by step something that's important. I'm looking forward to like more people kind of digging into this and helping us clarify this, and maybe some better instruction tuning data sets, so then we won't even have to worry about this. But this is something that when you're working with these explanations, it's important to remember. You're also going to get better results if you do better prompting. So if you give prompts such as few shot approaches that are calibrated, where the examples, line up with what you think the explanation should be, you can get a better performance. So I promised you I'd finish in a half hour, and so I'm just about here. So I think, this explanations is really weird. Like a lot of people in the literature focus on, hey, let's get the best possible classifications, but I just have lived in a world where I have to explain those classifications, or I'm like, I want to understand like why the model said, put it in a particular category. And so this is where if you're using like a simple distill bird or a bag of words, like good luck trying to really explain that. But the fascinating thing is these models do a nice job of like, especially if it's like a paragraph, of like pointing out what are the key facts there. And in my own little testing, I figured out that the larger model works a little bit better because it just has richer knowledge. It's better able to explain things to you. There's a lot of emphasis here on prompting, because prompting can vary the performance quite a bit like that. I think a lot of times we don't recognize how good models are because a lot of the benchmarks that are used don't spend time doing the prompting of, hey, you're an expert, hey, you're under duress, like all the little tricks that can get you better predictions for a given model like that. Now, of course, like the explanations are going to be limited by, it's got to be things that the model knows about, it's reasonable for it to do it. If you're asking for things way outside of the domain, it's crazy. If you play around with this stuff, let me know what you find. It's a rich idea, and I haven't seen a lot of people spending time on this. So, all right. I appreciate all of your efforts to kind of listen. I'm going to take some time for questions, but I just want to again highlight, evaluation is really important, especially if we want to get these things in production. Think about using models for evaluation. It can greatly improve the kind of the speed and quality. Check the button, get your explanations from your LLMs. Let me know what you find out with that. All right. And of course, I got the GitHub. Contact me on social media, all of that stuff as well. All right.
All right,
Let's go. Yeah.
Raj. So we have four in the Q&A and three in the chat. The ones in the chat are a little bit further back, so I got
Yeah.
them for you. So someone asked, how does Mixtral compare? I think that was when you were going through
Oh, the language board
Gemini.
and all that stuff like that. And again, like this is like one of those like, does it really matter to you like how it does on a leaderboard? Because at the end of the day, like you're using this for some specific task in your organization for something. So this is where like I tell people like build your own private leaderboards for this stuff, like on the data sets and the problems you care about, because that's really how you should be evaluating them. Like, yes, there's going to be the horse race out in the world of how these models do, and right, the mixture of experts is looking really good like that. But um, you know, you got to solve your particular problem and plug it in there. And so that's where I say that and stuff.
That kind of goes towards well, the next question in the chat was, can Hugging Face document prompt experimentation like A/B prompt testing?
So, and I didn't even really spend much time talking about Hugging Face. I'll get in trouble for that. But Hugging Face isn't the same thing as something like a Reese that is set of tools. It's Hugging Face is where you go to find your models. It has a model repository, dataset repository, and a lot of the underlying packages that you use, like transformers, is what Hugging Face does to kind of build the open source community like that. So when you're getting into that specific pieces like that, like Hugging Face really doesn't have the tooling in that same way for that.
Okay, so you said if you can't talk too much about Hugging Face, which there's a question on
Yeah,
what are Hugging Face's biggest priorities on LLMs for 2024. So I'm not sure
yeah.
exactly what you can say on that.
Well, so I mean, what I would say for that is really Hugging Face follows the community. I mean, we're really driven by where the community is like that. So if we see energy in our particular open source, in the open source tooling like that, you see lots of requests come in for a specific feature. We see lots of excitement on kind of Twitter or LinkedIn for a particular model or something. Like we follow that interest, and right, a lot of the work is driven by the community as a whole like that. So a lot of it is we don't kind of lead the community in a particular way. We kind of follow where the community is going. I think it's going to be an exciting year this next year. I mean, just this last month or two has been crazy where like every week there's like at least two new models released that are kind of earth shaking like that. And I think that is going to continue to grow as more and more groups have access to kind of GPUs and more models. Like they take a few months to bake. And so we're going to get lots more models over the next 6 to 9 months like that. So it's going to be an exciting time where we're going to have lots of large language models, as well as the big organizations, folks like Meta releasing large language models as well.
Awesome. And then we had one that was, I'll click answer live. This was more of a comment
Mhm.
that it's a very clever approach. I think this was one of your slides where you talk about defining the metric you want to, when you define the metric you want to use to the LLM, like as an approach. And that was a little bit earlier on. And I think that might be kind of towards what people are most interested in, like being able to like define things for LLMs to use, like essentially like having an assistant. So I kept that one up there. Uh,
Yeah.
and then we had a question from Shadrach on what is the relationship between explainability and causality. I'm wondering if you had did you have a slide on that
I
or?
didn't have a slide on that. I try to typically avoid the causality thing. Right? The causality thing can become very difficult to do, and the causal ML folks have very strict definitions around that. So if you really want to kind of prove like, one thing, one thing caused another thing, like it's not a trivial thing to be able to prove that. And often when we talk in the world of machine learning and kind of the type of data that we have, for a lot of problems, people aren't set up in those frameworks, don't have that data. So if you're working in areas where that's really important, so take a look at folks working on, for example, medicines and diseases, like causality is really important. Like you got to know which medicine caused that. They have frameworks that they'll use for causal machine learning to do that. Most folks, the general explainability combined with domain knowledge is good enough. Like folks that are working on a churn model, for example, they have an idea of what are the causal factors, what are the factors outside their control. And usually that amount of domain knowledge is good enough for kind of understanding what's going on with that. So I don't want to diminish causal ML. It's just I find it kind of a very difficult area to get into that often doesn't have that much value for most practitioners.
Okay. We'll get through the 5 open questions in here and then probably be able to tag you, Raj,
Yeah.
in additional questions in community. But feel free to comment what are your favorite topics that Raj is speaking to on evaluation for his social media. And I did answer the questions on what is your TikTok, what is your YouTube. So I sent out the links for those. Okay, question from AJ. Does it make sense to consider the question of evaluating the evaluators?
Well, absolutely. So, I mean, if we talked about so take something like we want to evaluate this the so we want to use a evaluator for sentiment. So you might have a sentiment model that you're going to use to evaluate the outputs of your model to make sure they're all happy. Well, of course, that model that you're using for evaluation, you're going to want to check to make sure it's really doing what it is. You might have some gold standard evaluation data that you've taken to make sure that that model as an evaluator is working. So this is where, as this model as evaluator gets more important to you, you should be evaluating and making sure it's really doing what it says. So, I gave the example earlier of the professionalism. You could see some use cases where like, it's kind of important, but not that important, where maybe you just stick a finger and just look at like 10 examples and see like, hey, is it working okay? But on the other hand, like if you're really rolling this out big time, you might be like, well, let me collect 100 examples and make sure that this evaluator is really working the way I intended it to before I scale this out to, 1,000 or 10 million. So, absolutely you want to judge these evaluators, and usually kind of it depends on how critical and how important it is for how much effort you do on that.
Perfect. And then a follow-up question to that, how do you evaluate how do you evaluate that the explanations are better than the ground truth, like quantifiably?
Yeah, so in that case, I don't think it was quantifiably. I think it was just basically the people looking at it and they wrote it in the paper that the people were like, wait a minute, like this ground truth or the explanations were better than the ground truth. So it was literally a qualitative measure in that case that it was better than the ground truth. But it's anybody that's like worked on these types of problems with like sentiment, for example, like financial sentiment or sentiment, you can see like these models like ChatGPT are really good at understanding the common things like sentiment, and they can often give a much more nuanced understanding that your black and white data might not have like that. So, I mean, for me, it's not an unusual thing at all to say like the models can give insights that your ground truth might not have.
Yeah, I completely agree there. And then I think this was after you mentioned like building your own leaderboards.
Mm-hmm.
Do you have any notebooks that you can share about building your WAN leaderboards? Or if anyone in the audience has kind of built their own leaderboards, I think like evaluation templates are a little bit more common, but
Yeah. So over at Hugging Face, we started with like the open LLM leaderboard that most people are familiar with. I can grab the link here in a second. But along the way, if you type in leaderboard into Hugging Face and Spaces, you'll see that there's a lot of other leaderboards nowadays beyond that. And so Clementine, and she's the one kind of leading the open LLM leaderboard efforts, has been working, and I don't know where she is, on kind of making it easy for people to build their own leaderboards around other data sets and other models. And so that's a thing I expect, because I have customers that are wanting this, that I expect over the next few months, you'll see it making it very easy that if you want to build your own leaderboard where you want a subset of models and you have your own data sets or benchmarks, it'll be pretty easy to do on Hugging Face. And I think there's a lot of people that have already figured it out because I see lots of leaderboards out there as well.
hmm hmm yeah, I still think Hugging Face is maybe the most searched and the most used. But yeah, definitely a few other leaderboards, but I think
Mm-hmm.
people are really interested in the variety of metrics that they're seeing for them. Um, Matthias asks, have you tried fine-tuning a Mistral 7B with a GPT-4 evaluation data set? A little specific, to build
No, yeah.
Mistral based evaluator or any other model?
If only I had the time. If only I had the time to do all this. So this is where you'll see
It
a lot
sounds
of what
fun.
I,
Yes, it sounds fun.
yeah, a lot of what I do is I just like look around and like aggregate all this other research and all these other studies, and I do a little bit of my own tinkering, but most of what I have to do is because it just takes a while to do this, and there's so many types of experiments you can run in this space. Is I kind of just try to keep an eye out on like what other folks have done that's interesting. So I'm sure somebody at some point will try that fairly soon. I think when you're looking at evaluators, the Prometheus model has been built to be an evaluator. It's been fine-tuned on lots of examples like that. So like my initial gut feeling is like that type of model is going to have a head start over doing something with Minstrel or Mixtral like that.
Perfect. And then we have some results from favorite topics. Um, let's see, favorite topics. We have two for explainability. Shadrach and AJ mentioned explainability with Raj is some of their favorite things. Evaluations. I think a lot of folks joined today because of the references to evaluation. So having TS other preference for evaluations. Foundational model selection and the criteria and considerations around making that first selection. Yeah, you kind of got like the paradox of choice when there's
Yeah,
so many models you can choose from. Um, let's see, real apps for production. So actually turning these LLM experiments like into production ready systems.
yes. Hmm.
Um, yeah, I like all the topics, especially when you're using the Arise slides. Model versus system, like
Yeah.
observability. Um, and let's see. I think there might be a few other ones in there, but those are the big ones we're seeing.
All right.
And um, yeah, we can kind of like summarize this chat for you, so you have that
Yeah,
information.
perfect.
There's a few more things coming in, but a lot of it is just thank yous and that these have been super helpful. And Raj is in our community Slack as
Yep.
well. Raj has a lot of ways that you can reach him. We sent out his media accounts. And so thank you so much for all these great questions and topics. And thanks, Raj, for joining. And yeah, I guess we're on Friday. Like some of us are approaching end of the day. So I hope this really kicked off your weekends. And thanks so much, Raj.
All right. Thanks, everybody. This was great.
Thanks. Bye, everyone.
Bye.